Hi there. What we're going to do next, we're going to do a couple examples of solving radical equations. And the first thing first is that we want to isolate the radical sign, that part. And before we go square it on the left-hand side. And it will, if we isolate the square root, the radical part, and the process will be much simpler. So first thing first, we subtract 3 from both sides. Now we have the radical part all by itself. Next, we square on both sides, square both sides, and square and the square root sort of canceled each other's functions. So it will left-hand side is just 7x plus 113. The right-hand side, 8 squared is 64. Then this is a relatively simple two-step equation, linear equation. So we subtract 113 from both sides. Then 7x is equal to negative 49 divided by 7 on both sides. X equal to negative 7. And we have solved this problem. So again, the key is that we want to isolate the radical part first. So that's the key for this type of problem. Okay, let's take a look at another example. Okay. It's quite similar to the one we just saw. So we have a radical part plus or minus a number and equal to another number on the other side of the equal sign. Again, it's a good habit to keep all your equal signs in the same vertical column so you can keep tracking which side is which side of the equal sign. Again, isolate this radical part by subtracting 2 on both sides. Radical part equal to 8. Square on both sides. That's the key approach for solving these kind of problems. You want the square root signs to go away. So undo the square root by square it. Left-hand side is 4x plus 36. 8 squared is 64. 2 more steps, subtracting 36. Your 4x equal to 28. Divided by 4 on both sides. Undo the multiplication part. X equal to 7. So you will be doing a couple problems, level 1 problems just like that. And they are completely doable. Now, next, we want to look at some level 2 problems. Okay. Now, you realize level 2 problems has a variable on the right-hand side. That's the only difference. And you have a radical part. And on the other side, you actually have a variable. So that distinguishes this type of problem from the level 1 problems. Level 1 problem doesn't have a variable on the other side. Okay, so, but the key point is the same. You want the radical part to be isolated first. You want the square root all by itself. If the 3 is on this side, you need to move it over to the other side. So you want the radical part by itself. If that's the case, from our experience looking at level 1 problems, we know if we square both sides, this square root sign will simply go away. And that's exactly what will happen if you square this original problem on both sides. Now, you realize that this is a perfect square. And if you use the FOIL method, and you should realize that x plus 3 times x plus 3 is x squared plus 6x plus 9. So now, that's why it's level 2 problem. It's actually a quadratic equation here. So the quickest way to solve a quadratic equation is to bring everything to one side. And the x squared is positive, so it would be very beneficial to move all the parts to where the positive x squared is located. So subtracting 10x from both sides, subtracting 30 from both sides, the left-hand side will be reduced to 0. And the right-hand side turn into x squared. And then you combine those two like terms, 6x minus 10x, and you got a negative 4x. Positive 9, negative 30 combined together, you get negative 21. So you have a quadratic trinomial on the right-hand side. And next thing you need to do is factor this quadratic trinomial. The strategy is looking for two numbers. You know half of the items already, so it's x and x multiply give you x squared. And you're looking for two numbers. Multiply give you negative 21. Combine together give you negative 4. And that's how exactly should be factored. And once you got that, and you separate, use principle of zero product, x plus 3 equal to 0, it would have worked. Or x minus 7 equal to 0 would also will make this equation work. So if x equal to negative 3 or x equal to 7, that would have reduced the right-hand side to 0 product. So here we go. Those are two potentially the solutions to this equation. However, you have to do one extra step. You have to verify if those are good answers. So how do we do that? You just plug it back into the original equation. So let's first check x equal to negative 3. So replace the x with negative 3. So original problem was 10x plus 30 square root is equal to x plus 3. So plug it in. If you did that, negative 30 plus 30 is 0. Right-hand side is 0. 0 equal to 0. Very good. We verified that x equal to negative 3 is true. So that's a good solution. Next, we want to check x equal to 7. By the same token, we take the same approach, put the 7 where x is in the original problem and evaluate it. Left-hand side is 70 plus 30 is 100. Square root of 100 is 10. And the 7 plus 3 is 10. And 10 absolutely equal to 10. So that it's true. Therefore, the final solution for this problem are indeed negative 3 and positive 7. So if you are using a online app to practice these problems, at that point, if the program is asking you what are the solutions, now you can safely enter negative 3 and 7. And you should get a green check for your effort. And you will, the program will tell you you did it correctly. You can move on to the next problem. Okay, we will look at one more example on solving radical equation at this level 2 caliber of problems. Okay, so here we go. We have a square root on the left-hand side, and we have a variable plus a number on the right-hand side. These are the level 2 problems. By this time, you know, as long as the radical part is isolated, you can square both sides. Square root sign disappears, and right-hand side is a perfect square. So realize that's a quadratic equation here. So you want to move everything to where the positive x squared is located. So you subtract 9x, subtract 58. That will reduce the left-hand side to a 0 because opposites cancel. And the right-hand side, you combine like terms. You have only one x squared, so you still got the x squared. 16x and 9x are like terms. It turned into positive 7x. And positive 64, negative 58 combined together, you get a positive 6. Perfect quadratic trinomial on the right-hand side. Let's factor it. And if you factor this quadratic trinomial, you will get x plus 6 times x plus 1. Because if you FOIL it, you will get your trinomial back. So x times x, x squared. 6 times 1 is 6. 6 plus 1 combined together is this positive 7. So you have two potential candidates. Again, x equal to negative 6, x equal to negative 1. Before you put that into your program, online app, you need to check whether they are indeed right solutions or not. If this one doesn't work out, you only put one answer there. If both doesn't work out, you have to put in no solution, okay? So you need to check those. The word we use that for extraneous roots. That means those roots that will not work out. We'll check for extraneous roots. Again, just like last example, first plug in x equal to negative 6 into your original equation. And 6 times 9 is negative 54. Negative 54, so it's positive 4. Negative 6 plus 8 is 2. Square root 4 is 2. So 2 plus 2, 2 is equal to 2. Will always be true. So x equal to negative 6 works. We have checked it. It's a good solution. Next, we want to check the other one. We want x equal to negative 1. Plug in where x is. Negative 9 plus 58 is positive 49. Right-hand side, combine negative 1 and 8, it's 7. Square root 49 is 7. Left-hand side, 7 equal to the right-hand side, 7. So again, x equal to negative 1 is also a true solution. So there